So this very first question is exactly like what we did on Friday. So we're given a function, and again, we talked about how this is just a new notation. It's similar to y equals 3n squared minus 4. We only use it for functions. That's why it's called function notation. Functions are special relations. We just talked about taking up the learning goal. They're important in mathematics, that something is a function or not. And so we're just getting used to the new notation. So this is p at n equals 3n squared minus 4, and then it wants us to do p at negative 3. So this is telling us that our n equals negative 3. So I can substitute negative 3 in for n in the expression. And then I just evaluate. Yep.
You put a negative 2.
Oh, thanks. And then I just evaluate it. And be careful with this because, you know, with the negatives and the BEDMAS, making a little mistake can make a big deal. But this should be negative 3 all squared. Negative 3 times 3, that's 9. Do exponents first. 3 times 9 is 27. And 27 minus 4 is 23. Easy enough. Same thing for the next one, just kind of warming up here. Negative 1.5 decimals. When we square decimals, that can be a little bit messier. So use your calculator, make sure you know how to do it. Again, the negative is inside the bracket, so it's going to go away. So I put 1.5 into my calculator, square it. .25. BEDMAS, exponents first, then I multiply, so times 3, that gives me 6.75. And minus 4 gives me 2.75. Everybody okay with that? It's pretty straightforward. Remember the notation. Here's something that's a little different. What does it mean when there's like an expression in there? Well, remember what I said. It's telling us what n equals. So this is saying n equals 2x plus 1. And I sub that in for n. Okay, so if n is 2x plus 1, I put 2x plus 1 in place of n everywhere that n is. There's only one n in this one. So 2x plus 1. I sub it in for n. And what's 2x plus 1 all squared? You don't have to write this out long, but I'm gonna do it an extra step to remind us what it means. We did this when we were warming up at the very beginning of the year, before we really started getting into new stuff. Just put your pencil down for a second and watch, actually. A lot of people think that it might be this, 2x plus 1 all squared is like 2x squared plus 1 squared or something like that. No, you don't just square both terms. It's the thing times itself. And how do we do that? It's 2x times 2x and 2x times 1. And then 1 times 2x and 1 times 1. Right? And I'm going to do that first. I'm going to leave the 3 out. So 2x times 2x is 4x squared plus 2x plus 2x plus 1. And notice I'm writing the whole thing down, so it's a little bit more work than the last ones we were looking at. But again, this becomes really powerful with function notation. I can easily do this kind of stuff, and it turns out we do a lot of this kind of stuff in math. Distribute the 3 into the bracket. Remember this, 3 times each one of those things. So I got 12x squared plus 12x plus 3 minus 4. And that works out to 12x squared plus 12x minus 1. Just like that. Any questions about that? You get that okay? And then question number 2 is sort of more the same, sort of just different kinds of things that might come up. And we're, again, practicing with the notation, but some slightly different questions than we saw before. So this is saying f at 1 plus g at 3. And there's f at x, and there's g at x. And I have different x's. So again, this would be hard to do with that old notation if you wanted to write something like this. So you could do it all together in one step, but some people might like to do it off to the side, so we would go like this. F at 1, whoops, is 2x minus 3, so I put a 1 in there, and that's 2 minus 3, which is negative 1. And I do g at 3, which is 3 squared plus 3 minus 2. Am I going too fast? 9 plus 3 minus 2, which is 12 minus 2, which is 10. That make sense? Okay, and f at 1 is negative 1, and g at 3 is 10, and so that I'm just adding them together. But you see what I mean? I could have done each of those in place here. I don't have to go off to the side and do them, but it does show maybe a little bit more nicely exactly what we did for the first one. Okay? Okay, next one, same thing. What does 2 f at x mean? That means 2 times f at x, which is 2 times 2x minus 3. Because that's f at x. And I just expand it. 4x minus 6. And then 3 times g at x is 3x squared plus x minus 2. All of this is just practice getting used to the notation, different kinds of questions that you might see pop up somewhere that we use function notation for. Okay, so now 2f at x, I calculated that over there, so that's a 4x minus 6 minus, careful, put your pencil down and watch. This is something a lot of people get wrong. They do this, minus 3x squared plus 3x minus 6. But it should be minus all of that. So whenever I'm subtracting an expression, I need brackets around, and then I need to distribute that negative sign into the brackets. Oops. Minus 6 minus 3x squared minus 3x plus 6. Collect like terms. Negative 6 plus 6 is 0, so that's gone. Oops, I did that wrong, didn't I? That should be 4x goes with 3x, so that should be negative 3x squared plus x. That looks better. X's go together. Any questions about that?
When we put in the brackets on the right side of the line,
Yes.
do we use that
That's what I did this time. That's right. If we did, so what you're asking is like this. Whoops. If I put it by a -3 because that's like a -3. If you did, then you would be adding here. So you would just have to make sure you did that correctly because you already used the negative. Does that make sense? Yeah. You could do it either way. Yeah. Okay, one more. G at f at x. What does this mean? Well, what is f at x? Remember, f at x is 2x minus 3 from the beginning of the question. So this is g at that. And remember what I said, for this notation, you just stick that in place of x everywhere, but now we're talking about g. So g is x squared plus x minus 2. And what's my x? It's 2x minus 3. Why don't you go ahead and try expanding that and simplifying it for practice? You never get that. Yeah. In grade 12, you do cubic expansions, like 2 to 3. We started looking at that a little bit, but never really, because it would just take. How'd we do? I got 4x squared minus 10x plus 4. Is that what other people got? So I did 2x times 2x is 4x squared, and then 2x times -3 and -3 times 2x is those two terms. -3 times 3 is +9. And then I just collected like terms. Okay, on the back of your page, we've got a bit of an application here. Cost of hiring a plumber is $75. We talked about this kind of idea before. $75 for a service call and $30 per hour for labor. That's a good price. A lot of the time they're a lot more expensive than that, $30 per hour. The cost of hiring this plumber can be expressed as an equation. And notice I used function notation for this one. C at T equals 75. That's the fee to show up, plus $30 per hour. So T is the number of hours. C is the total cost in dollars. Which one is the independent variable and which one is the dependent variable? Do you remember talking about this? What do you think?
Is C dependent?
So why do you say that?
Because how much you have to pay depends on how long it's there for.
Very nice. I like how you said it too. Like say that sentence in your head so that it makes sense. How much you pay depends on how long they're there. So C is the dependent variable and T is the independent. Remember what I said, time is basically always the independent one because time just goes. Other things don't cause time to go. Time goes. So it's independent. And we say cost depends on the number of hours or time. Is the cost of, this is a bit of a strange question, but is the cost of hiring a plumber a function of the number of hours worked? So is it a function? I mean, I used function notation already, which is kind of a tip, but our answer here is going to be yes. How do we know it's a function? Well, for one, it's a straight line. If you know a little bit about those equations, and when we work with this, you'll recognize them more and more. We know that a linear equation is a straight line. There's no exponents in the equation. So it's not curved, it's straight. But also, if you think about it, each amount of time worked results in a different total cost. You work for 1 hour, it's going to cost one thing. You work for 2 hours, it's going to cost something else. You work for 2.5 hours, it's going to cost something else. 2 hours and 50 minutes, it's going to cost something else. So every amount of time that you work will have a different cost. You will never have the same cost, right? And that makes sense. Remember I talked about this. If you had some equation that wasn't a function and you worked for 3 hours and it gave you 2 answers, how would you know which one to pay, right? So it wouldn't make any sense. Also, this is a straight line. Which is a function. State the domain and range. Now, if I were to just graph this, it would be a line that would go everywhere. But in the real life, what is the possible? So the domain is the possible values for the independent variable. So t. So what can t be in this case? Like in the real world? Can it be negative? Can time be negative?
So would it be when x is smaller than 0?
Not smaller than. Yeah, because when x is smaller than 0, it doesn't work, right? So, but our domain is going to describe what does work. Does that make sense? So the domain is actually t is an element of the real numbers such that t has to be greater than or equal to 0. Now, why you would have a plumber show up to your house and stay there for 0 minutes and you pay them $75 and then tell them to leave, I have no idea. So even then, like realistically, nobody's ever going to be charged for 0 hours, I don't think, right? But when we're talking domain, that makes sense. But it doesn't make sense for t to be -1. Then he pays you money? Is that how that would work? I don't know how that would work, right? Okay, so range C for cost. And notice we're not using X and Y. We're using the actual letters from this question. C is an element of the real number such that, what's this one going to be? Is there a maximum total cost? I mean, no plumber is going to stay at your house for 4,000 hours, but like technically the equation would work. Is there a maximum? What do you think? Is that the maximum cost? Is there a maximum cost? Could the plumber keep working forever and ever? There's no maximum, right? It could keep going. Maybe the company says after 12 hours we quit, and then you would have something different, right? But if T goes up forever, the cost will go up forever. What's the minimum cost? 75. Because even for 0 hours, it would cost you 75. So T will be greater than or equal, or sorry, C will be greater than or equal to 75. And this is where we start to see a little bit of how domain and range is actually useful. Thinking about in a real world situation, what are the possible values that make sense for this to be true? And if I was going to graph it, you probably did this back in grade 9, I'd graph it starting at 75 and I'd show that it goes up. So it doesn't go to negative t's and it doesn't go below 75. What would be the cost of hiring a plumber for 6 hours? So that's C at 6 equals 75 plus 30 times 6. So that's just plugging in and solving like we've been doing, 225. If a question ever like is asked in words and has a unit as an answer kind of thing, like dollars, when we do the work over here, I don't have any units, I just have this number 255. So that's another reason why sometimes we write it out as an actual answer. And I know it seems kind of like a waste of time, but you know, for a test, you would answer with a sentence and include the units. So it's not just a number 255, it's like $255. How many hours can a plumber work for the cost to be $360? I suppose a customer could say, all I can pay, the most I can pay you is $360. That's all I have in my account right now. So work until that runs out and then you got to be done. If it's not fixed, it's not fixed. I suppose that could happen, right? So how do we do this? This means the cost is $360. So that's $360 equals, so I'm subbing in on the other side. And if you haven't noticed, this is a really common thing, that an equation C equals 75 plus 30t. I can sub in for t and solve for c. I can sub in for c and solve for t. You can do both. Okay, so I'm going to subtract 75 from both. 360 minus 75 is 285. And divide both sides by 30. T equals 9.5. Therefore, 9.5 hours would cost $360. Any questions? Okay, you should see your homework on the handout there. Over the last few days, we've been working in the same page, so there's some stuff from that same page that's posted online, but I also have a handout for you. See, there's a little bit of stuff to do for both. Tomorrow we're moving on to something not new because you've seen it before, but we're doing something different from function notation. So hopefully by the end of today, you've done the practice, you kind of are starting to get function notation better. There's some questions that are just practice, but there's some different kind of questions in there too that make you kind of think. I don't know if you noticed, like questions 13 and 14, 15, 16, those ones that have been assigned are a little bit different. So hopefully if you didn't do all of them, you can go back and take a look at them as well.